What's up, you guys? Welcome back to the channel. In today's video, I'm going to show you how to create this complete classic helicopter flying game in Python code using the Pygame module. We're going to do it from scratch. Alrighty, so as with every Pygame game that we do, step one is import Pygame. If you don't have it already installed in your package, just go ahead and run pip install Pygame. And then right in the beginning, just do pygame.init. Make sure you spell it right. Pygame.init. And I'll try to go pretty quick through some of the generic stuff that we do in every video, but this is an important step. So we do want to put height and width of our screen into a couple variables because we're going to use those in a lot of positions, like for drawing the obstacles for the helicopter. So we're going to want these in variables. And then to actually use them, it's screen equals and then pygame.display and then .set mode, and you just give it width, comma, height like that. Okay. And then if you're gonna want to change the caption, it's pygame.display.set caption, and then you just put what you want it to be in there, and we'll say helicopter in Python, just like that. Okay, and then if you're going to have any text, which we're going to display the score, stuff like that. Then you want to say font and set this up as pygame.font with a lowercase f, .font with a capital F. And I'm just going to use freesansbold.ttf because that is a font that comes with most installs. But you can import a more fun font file here if you want. And then we're going to set up a frame rate, which I'll make my frames 60. And then you need a timer. So timer is going to be equal to pygame.time.clock with a capital C. And that's really all we need for just base project setup. Now we want to do our main game loop. So we're going to make this variable run, and it'll be true initially. And we're going to say while run. So until something stops that run variable, we want the following commands to happen every time, over and over again. So first thing we'll do is we'll just fill it with a background color, and I will use black. And then you want timer.tick at your frame rate. So that just controls the speed at which your game is going to move. And then we just need to figure out how to get out of that while loop. So that's the most important first step when you create a while loop, is make sure you don't create an infinite while loop. You need to have a way to get out of it. And so to do that, we'll say for event in pygame.event.get. This is the event handler of Pygame that will get everything happening with your computer. So mouse clicks, keyboard clicks, anything like that. And then we'll say if the event that happened is equal to pygame dot and then the specific .quit command. And if that is true, then we'll set run equal to false, and then we'll come out of our event handling here, and we'll say every loop we want this pygame.display.flip, which just throws every visual element we generate onto the screen, and then pygame.quit outside of that while loop. So while run, we're going to do all these things. If they hit the quit button in the top right of our window, then we'll set run equal to false, so it'll come down here and it'll do pygame.quit. And that should be all we need to do to get our base window. So here you can see we've got a 16 high, 1000 wide. I tried to go with about the screen size of the classic game, but feel free to play around with that. And so the first thing we're going to want to do really is we're going to want to handle generating a random map when we boot our game up. So we're going to make a variable that I'll call new map, and it's going to be equal to true in the very beginning, and it's going to be equal to true anytime that we restart the game. So we'll come right after timer.tick, and we'll just say if new map. Then what we want to do is we want to generate a new board. So we'll say all of the rectangles in our board, our map rects, are going to be equal to a function that we'll call generate new, just like this, okay? And then we're going to set new map equal to false, because anytime new map is true, we just want to do this once. So now we have to take a look at what we're actually going to do with the generate new function, and it's not going to be that hard. So define generate new. We don't have to pass anything in, and then what we want to return is basically a list of rectangles. All right, so let's take a look at how we're going to do this. First of all, let's just go ahead and put this rects list initialized in here. just as an empty list. And then let's grab the first height of our first rectangle, right? So whatever we want the height of the first top rectangle to be equal to, let's get a random value. So random.randint 0 to 300. And you do have to import the random module. So you need this import random up there with your import Pygame. That should come with your Python installs, but you can run pip to install it too if you need to. Okay, so that's going to be the first top height that we are going to use. And then what we want to say is for I in range, and we need to calculate the total number of rectangles that we should have. And I actually think the best place to do this is not going to be inside this function. I think it'll actually be in our initialization. So it's definitely possible that you'll want to play around with these values in your version of the game. But basically, I'm going to make an empty list of the map rectangles out here, but I'm also going to do a little bit of math, okay? So I'm going to decide how wide in pixels I want each rectangle to be. And this is something we can play around with in a second, but I'm going to say 10 initially. When I was playing around with it, that looked pretty good. And then the total amount of rectangles we want is going to be equal to the width of our screen, floor divided by the width of our rectangle. And so floor division is how you get an integer value no matter what. So if for some reason your width was 1001, this would round down to the lowest integer value. Okay, so we're just going to do that in the beginning so that we can reference it in this function, but we can also reference it in other functions if we so choose. All right, so for I in range, total number of rectangles, what do we want to do for every rectangle? We want to select a top height that is going to be close to the previous top height, right? Because we don't want to make it impossible to get through our channel. We want it to kind of look like a carved continuous path. So the new top height will be our random.randint. And for this one, instead of using the just raw 0 to 300, we want to make sure that it's within, I guess, plus or minus some spacer that we're going to determine. So the smallest value it could be would be top height minus some spacer value. And the farthest down it could be would be top height plus some spacer value. Okay, so that'll be one more variable to put up in the beginning. And I'm going to put a 10 in here, and then once we generate this map and draw it on the screen, I'll show you what kind of tweaking like this rectangle width and this spacer value can get you. But basically what we're doing is for every rectangle, we're going to grab a new height for it that's within plus or minus our spacer value of the previous rectangle. That way, there's not going to be any huge, really bizarre jumps in the kind of elevation change. But then we also need some limits. So we need to say if top height is ever less than 0, right? So if for some reason the top height of the first rectangle was 5, and then the random selection chose 10 minus that, so -5, we don't actually want a rectangle that can go off screen. So we want to limit top height equal to 0. And then I think a good gap to have between the top and the bottom rectangle is 300 pixels. That's kind of why I did it 0 to 300. I know I didn't really touch on where that 300 came from, but that's half the screen. So basically, I always want the player to have a gap of 300 to fly through. So then we need an elif here that's basically if top height ever gets greater than 300, then we want to set top height equal to 300. And so now you're probably saying like, okay, that's fine, but we've kind of done all this talking about the top height and we haven't really used it. So now we're going to. Basically, our top rectangle is going to be pygame.draw.rect, just like this. And then we're going to put it on the screen. And you probably saw in the intro, the classic game is, these are just like neon green blocks. So I'm going to make mine neon green to stay pretty true to that. But you can definitely play around with color here if you want to, and make them, blue, red, whatever. You could even make it change colors as the score increased if you really wanted to. But now we have to be very careful on the rectangle definition. So the X starting position should be I times rectangle width, right? We're going all the way across the screen. I is our index variable in our for loop, and each of them should be as wide as our variable rectangle width. And then we want to have the Y starting position. These are for the top rectangles, remember. The Y starting position should always be 0. So it's always starting at the top of the screen. And then for our, don't close that yet. There we go. And then for our, goodness. Excuse me, sorry about that. So that's our X and Y starting position. Then for our width, which is pretty easy, it's just rectangle width. And then for our height, it's actually very easy too. It's going to be that top height variable that we just defined. And I'm just going to leave it as a solid rectangle. I don't need rounded edges or anything. But so this is going to give us a row of rectangles across the top of the screen that will be within our spacer value of the previous ones. And this is just going to give us a really cool top row. And then the important thing to do for the bottom row is just understand that we want like a constant gap, in this case 300. And so we can copy this pygame.draw.rect, but we do have to change several things about it. So the X starting position, that doesn't change. But the Y starting position is actually going to be top height, so that variable we found, plus 300, which is basically our gap. And if you think that you're going to want to mess with the gap that the player flies through, you can make this a variable instead of 300. I don't want to mess with that, so I'm going to leave it 300. But we can then make the rectangle width the same. And then for height of this, you could do some like complicated math to figure out how high the rectangle is and just draw it to the bottom of the screen. But actually, if you make it too long, all it's going to do is draw off the bottom of the screen. So I'm just going to use height here for convenience, but you don't have to. Like, this is going to be more than enough always, because basically the longest a bottom rectangle will ever be will be 300, right? So you could just get around that and say 300 here. I don't really care. It's not going to chew up a bunch of processing power. So then you want to add these rectangles to our list, because we're going to use them for collision detection and a lot of other things later on. So we want to rects.append the bottom rect. And then this is cool. This is saving our rectangle objects to a rectangles list. But because this is how we generate a new board, we're not actually going to be drawing these onto the screen every iteration of the loop. So what we need to do, that's all it takes to generate a new board in the beginning. But what we need to do is we need to make a function called drawMap that's basically going to draw those rectangles every single iteration of the loop. So we'll just make this function drawMap, and we're going to pass in the map rectangles that we should have just gotten from generate new, right? And we're going to come right underneath our generate new function. And now we're going to make a function called draw_mapped. And we pass in our list of rectangles. And this is super simple. It's just for I in range length of rectangles. Then what we want to do, rectangles. Then what we want to do is pygame.draw.rect on the screen, color green. And then for the rectangle, we're just going to say rects at I, right? So we have all these rectangles defined in our rects list. So we're just going through one at a time, drawing them on the screen, color green. And then what I found just makes it look a little bit more professional, look a little bit better, and help define the edges, is I just chose here to make a dark gray border around the entire screen. This is totally an optional step, but I do really like the way it looks. So it just starts at 0, 0. It's the full width and the full height, and I gave it a frame width of 12. It looks good to have a border on this project. This is not necessary. But okay, so this should be everything we need to get the board initially created and randomly generated, and then also have it drawn on the screen. So let's take a look. All right, so you can see I've got this kind of lower half slow arcing like curve to it, which is pretty good. But if I boot it up again, I should get a totally different board because it's completely randomly generated. So let's try it again. And now you can see it's up at the top. And so now I want to briefly touch on, you can kind of see each individual rectangle to the next is not a ton of variation. You do get some cool shape, but if you want to mess with that a bit, then what you change is your spacer variable, right? So if we said 15 instead, and then we booted it up, now you can see you get, occasionally you get bigger steps in it, and it can make it a little more challenging. And what you'll see here is if we made that spacer like 25, you could get some very big single rectangle jumps. And so like if you had 2 straight that were close to your limit, you could change by an entire like 50 in just 2. So I am going to leave it 10 for now, but you can play around with it. You could also play around with like rectangle width here. So if I made it 20, if I made it twice as wide, you can see it's actually kind of a lower def shape. You know, so if I were even to make this like 5 wide, right, you're going to see a lot of really wacky shapes. And you'll see it's sort of just increasing definition in it. You could even go down to 1 and you would get a really spiky kind of path through, right? It's kind of like sound files almost. So that's just, I wanted to touch on what those variables are really doing for us, but I'm going to leave rectangle width at 10 and I'm going to leave spacer at 10 for now. Okay. So now let's go ahead and take a look at what we should do next. And I think the next thing to do would be draw the player and then also move the player and move the rectangles, right? So let's go ahead and draw the player. And I'm going to use a circular like hitbox for the player, and we are going to actually import a helicopter shape a little bit later, but for now I'm going to make the player a circle just so we get the player's hitbox so we don't get too caught up in style until we get the functionality working. And so for this, we're going to make another function called draw a player. And something I'm really trying to do more of in projects is you really use object-oriented programming the way it's supposed to. And so break all of these functions, even if they're only a few lines apiece, out into their own functions rather than stuff them all in the game loop. So, all right, so we're going to want 2 new variables for this. We're going to want a player X variable, which I'll just put it at 100, so it's kind of off of the left edge of the screen. And then we want player Y, which I'll make 300 just initially. It doesn't matter because actually what we're going to do is come down inside our generate new function, and we're going to just call that player Y as a global so we don't have to pass it in and out. But when we define the top height right here, one more thing that I want to do is just define that player Y coordinate as the top height plus 150. And so if you think about it, we said the player will always have a 300 pixel gap. And so this is going to stick the player right in the middle of the gap when we generate a new board. And now this function and this function can officially just be closed while we work on other functions. So let's take a look at the draw player function now. Define draw player. And basically, we don't have to take anything in because all we're returning is our player like circle. So the location and hitbox for the player, which is just going to be equal to pygame.draw.circle. And we're going to put it on the screen. I'm going to make this initial circle white so it's really easy to see against a black background. And then for a center point, we're just going to give it the player X and player Y coordinates we just came up with. And then for a radius, I'm just going to use 20. So we're in a gap of 300. A radius of 20 might seem like you're giving the player a ton of space. But as the speed starts to increase on this game, that's actually still going to become very difficult. So totally something you can mess with if you want. And we will come back to this later. And we'll also, this is where we'll draw player hitbox as circle and player helicopter image. So we're going to do the player helicopter image, but first we're going to talk about how to use that hitbox and how to kind of move the player and move the rectangles. So for now, if I just make this, we should get a white circle, directly in between our starting objects, right? So you could say that it doesn't really make sense to make the player's Y position in between the first rectangles, but in my experience, putting the player 10 rectangles away, there hasn't been a single situation where that hasn't been close enough to the original spot. So I think that looks pretty good. Now let's go ahead and take a look at how to kind of move the player. So the classic way to really move the player is with one key that you sort of hold down to get to move up, and then you release to move down. And it's sort of gravity based and momentum based, where the longer you hold it down, the faster you'll shoot up, and the longer you've released it, the faster you'll go down. This is similar to like Flappy Bird or Jetpack Joyride. I think, as far as I know, Helicopter was practically the first one to do that. So what we're going to do to move the player is we're going to make a new variable that we'll call flying. So when you're holding the spacebar down, you'll be given the helicopter some gas and you'll be shooting upward. And then when you release the spacebar, you'll start letting gravity do its thing. So we need some new categories in our event handling. We need if event, actually, this for event in pygame.event.get, we're going to add some new event types. So this probably shouldn't have worked. It should be if event.type is equal to pygame.quit, which I don't know if you guys are attentive or not, but you may have noticed up to this point I've been having trouble with the X button. I'm guessing it was because I just said if event is equal to pygame.quit, and I just answered something. I was trying not to panic and be like, why was the X button not working? But that's why. And there you go. We just learned something live. Troubleshooting. You guys are lucky. So now we want a new event type equal to pygame dot, and now we want not mouse button down, excuse me, key down. So just key down like that. And we're going to take a look at what to do with the space bar. So we need if event dot key is equal to pygame dot k underscore space. Okay, just like this. And if event.key is equal to k space, then we want flying equal to true. All right, and now we want to figure out, well, what's the opposite of that? If event.type is equal to pygame.key up, so you've released the spacebar, if event.key is equal to pygame.k underscore space, then flying is equal to false. Just like that, okay? Pretty easy. Pretty simple stuff, and all we have to do to use that is basically make a new function, obviously, underneath our draw player that we'll call move player. And so for this one, we are going to basically get back a new y coordinate for the player, as well as we want to keep track of the rate of change, so our speed in the y direction, using a new function that we'll call move player. And we need to pass in here, obviously, the player's y, the current y coordinate, as well as the current y speed, as well as whether or not we are flying. Okay, so we need to make a new variable here, obviously called y speed. And when the game boots up, we'll make it 0. So you're not going upwards, you're not going downwards, you're just sitting there. And now let's take a look at how to use that. So define move player, and let's make sure we get our variables that we said we'd pass in the correct order. So I think we said y position, and then our speed, and then if we're flying or not. And I think we said we need to return our y position and our speed. Now let's just double check that. Player y, y speed, and then whether or not we're flying, and we're going to pass back the y position and the speed. Yep. So this is actually not that hard. All we're going to do is say if flying is active, then we want our speed to be plus equals gravity. So we'll say that we move upwards in the same speed that we move downwards. Whoops. Okay. And then our y position will be minus equals speed. And then we'll say, whoop, come on, stop fighting me. And then we'll say else, meaning flying is not true. Then our speed is going to be minus equals gravity. Gravity, just like that. And then our y position will still be, yeah, it's fighting me on gravity because I haven't made it yet. So actually, y position minus equals speed is true no matter what. It's always, our y position is always changing. You don't have an option in this game to stay stationary. You either are going up or down, which is actually kind of the challenge of it. So we need to make this variable gravity. that's also going to be one of the things that kind of controls the difficulty of the game. And so you can play around with these variables if you want. I have found 0.3 to be you have a lot of control. It's fairly responsive, but you don't have so much control that it's impossible. Like, it doesn't change so rapidly that you can't get a handle on things. So now that really should be all we have to do. So if we boot this up, and I'm going to try to, I started by going straight up. Oh, so make sure you have the flying equals false to start because you want, yeah, there we go. So now if I tap the space key, I can kind of get the player to hover in place, which is kind of fun. And if I hold it down, I shoot up with more speed. And if I let go for a while, there's a pretty significant curve. So this is kind of like a little bit of physics-based change of direction. Gravity is sort of this acceleration that can change our y speed over time. So it's really change in velocity per time, which is what acceleration is. Okay. And so actually we're not going to move the player in the x direction. The way we're going to give the illusion of flying forward is by moving all of the rectangles on the board. And this is probably going to be the most complicated step in the process. And the best part is it's not even that complicated. Okay, so let's take a look at it. Right below where we're moving the player, we're going to want another function that we're going to call basically move rectangles. Okay, and so for this, we're going to sort of be overwriting our list of rectangles using a function called move rects. And all we're going to pass in here are going to be our map rectangles. Okay, so let's come below move player and define move rectangles. And then in here, we're still passing in this list of rectangles, and we're returning the list of rectangles. All right. So what are we going to do inside of here? Well, we're going to say for I in range length of our rectangles list. So this is basically saying for every rectangle in our rectangles list, we're just going to redefine rects at I equal to. And so now the thing about defining a rectangle is that you don't give it color when you just define it like this. You give it X and Y start position, and then you also give it width and height. So it's going to be rects at I0 minus a variable we're going to make called map speed. And to start, I'm just going to make map speed equal to 2, but we are going to make that get progressively faster the higher the score gets when we get to the scoring step. But so basically, we're taking your x starting coordinate and we're going to move it to the left by the speed of the map. But then everything else about the rectangle is going to stay the same. So rects I1, and then this is going to always be rectangle width. And then this is going to be rects I3. So we want the rectangle to stay the same vertical height the whole time it's on there. So basically, we're not changing anything about the rectangle except its x position. And then we need to do sort of some checking to see if our rectangle just got off the map. So we're going to say if rects at I0 plus the rectangle width is less than, and now we'll say just 0. So basically, you're all the way off the screen, right? Then we want to rects dot pop, and something to actually be careful about here is we want to pop two rectangles. So we want to pop rects dot pop. We want to pop both of the first two rectangles because the way we added to these in the generate new list was we added the top rectangle, then the bottom rectangle. We didn't add all of the top rectangles to one list and the bottom rectangles to another. We added the top rectangle, then the bottom rectangle, but they're in the same x position. So this means we want to pop the bottom rectangle and then the top rectangle to make sure we remove the right number of rectangles from our list. And then what we're going to do is we're going to select, if we did have to do this here, we're going to select a new top height equal to random.rand int, there we go, from rects -2. So this is the previous top one, right? So -2 means we're now selecting backwards from the end of the list. So -1 is your last element in the list. -2 is the second to last element in the list, which is going to be the last top rectangle, because the way we have it set up, we're always adding a bottom rectangle last, but we're going to use the top rectangle to get our new top height. Okay, so top height was 3 on that rectangle. So the options for this new rectangle are basically rects -2, 3, which is the top height, minus the spacer or plus the spacer. So this is how we're going to get a continuous board that goes forward as we play the game. All right. And so now we need to do the same if top height checks less than 0 and greater than 300. And actually, the easiest way to do this is just going to be to grab these 4 lines of code. And then we will actually use very similar top and bottom rect code. So, you could grab those and try to modify them, but I'm going to just think through what we're doing now. Okay, so this is actually pretty important. We're appending to our rectangles list. So we need to put the new rectangle in this list. And what it's going to be is that rects -2 plus rect width for starting X position -2, 0. So rects -2, 0 refers to the previous, the last top rectangle's X starting position. So this new rectangle is going to be that position plus the width of one rectangle. Its Y starting position will always be 0 because it's a top rectangle. Its width will always be rectangle width. And then its height is going to be this top height variable. And then we need to also add a bottom rectangle to make sure we keep these kind of standard orders of doing things. So we have rects -2, 0. And we're going to add to it the rect width. The X position doesn't change, right? And then it's top height plus 300, just like before. And then rect width. And then I'm just, to be consistent, I'm going to throw height in here as well. And then what we will do here, this is actually an okay time to incorporate scoring, I guess, too. So we'll call in the score variable, and we'll say anytime we've erased one new rectangle and drawn on, or 2 new rectangles, I guess, and drawn on 2 new rectangles, we'll call that 1 point. So let's go ahead and make a variable score that will just start out equal to 0. But we'll say you get a point every time you've moved a rectangle off the screen. Okay, so we haven't put any collision detection in, but just with this function that we just made, we should have everything we need to get the rectangles kind of moving as the player is flying through them. So let's go ahead and boot it up and see if it's working. Yeah, and you can see like map speed 2 is not very fast, but that's kind of to give the player a chance to like initially get their helicopter flying, get a feel for the controls, and then we're going to want to go ahead and make like progressive difficulty. But the last real game mechanic that's missing is we obviously don't have any collision detection. And this is going to be pretty easy. So let's go ahead and sort of take a look at how to do that next. So if we come down below our move rectangles function, then what we can do is we can create some variable checking like if game is over or if it's not. I'll call it active. But basically, all check collision needs to tell us is if we are colliding or if we aren't. And that'll set this active variable to either true or false. So we need to pass in all of the rectangles, and we need to pass in the player circle. And I guess we'll pass in active too. I'm not sure if we'll need that or not, but let's pass it in there in case we need it. And so now let's come up to our functions and let's just make a new one, which is going to be called, what do we call it? Check collision. Define check collision. And we are going to pass in here the rects, the circle, and then also active. And we are just going to return whether we should still be active. Okay. And just to briefly touch on, you've probably noticed all of my functions. I give the names inside slightly different names than the name outside. That's just because PyCharm in particular will give you this, it shadows the name active from the outer scope. That can create confusion when your code doesn't really know which active it's looking at. So I just try to change them up inside the function. Just wanted to touch on that briefly. Now, what we're going to say is for I in range length of our rectangles, right? So for every rectangle in that rectangles list, top or bottom, if our player, I think I called it circle, if circle dot collide rect, and this is a really nice function that Pygame has built in for its polygons, so you can check if our player's circular hitbox collides with the rectangle at, and so all you give in here is the rectangle to check for collision with. So if it collides with a rectangle, we're going to set act equal to false. Otherwise, act is going to be equal to true. So I guess this is the benefit of passing what it's currently set to in here. Otherwise, you would just want something like active equals true right in the beginning, but we don't need that. Okay, and so this should be all we need to do to create working collision detection. And then to see if it's working, we'll just make it to where our if active, to where our player movement and map movement only work if active is true. And so in the beginning, obviously, we want active equal to true. Okay, so if we did that right, then just with that very simple function, yeah, everything will stop moving when we hit a rectangle. So obviously the map's not moving very fast and the gaps aren't very big. So I could play this forever, but if I fly up into a ceiling target, it stops the game. So that's really cool. And that is legitimately the basis of all of this gameplay. So now what I think we should do is we should incorporate some of those real improvements to make this a much more fun game. So first, let's take a look at basically how to restart the game, right? So I think if we press the enter key, or it's called the return key in Pygame, but if you press enter on your keyboard while active is false, I think we should use that to sort of reboot. So we'll say if event.key in our pygame.keydown logic. If event.key is equal to pygame.k underscore, and it's called k return, but that's your enter key, okay? It's just because old-timey keyboards said return instead of enter there. I think it actually goes back to typewriters, which is awesome. So then we'll say if not active, meaning if you press the enter key and you've lost, so active is false, then we'll restart. But if you hit the enter key accidentally while you're playing, it won't do anything. But then we'll set a few things. That new map variable we made in the beginning, we'll set that equal to true. We'll set active back equal to true. We will reset the Y speed so that you're back to neutral. And then we'll reset the map speed to 2 or whatever initial value you want it to have. And then we'll say if score is greater than high score, which we obviously need to make a new high score variable, but then we'll set our high score variable equal to score, because then the last thing we need to do is we need to clear out our score. So this is just a quick, simple way to check if we got a new high score every time we restart. And so underneath score, let's just make another variable, high score. And we're not doing anything with those yet, but this should allow us, so like when I boot it up, if I was caught off guard and, oh, okay, I died, if I hit enter, yeah, it generates a new map, which is really fun. And now I can just sort of keep playing. So, okay, I've said several times we're going to make it progressively more difficult, which is going to be like a big improvement for replayability and making it fun and challenging to like beat your high score. So we're going to define our map speed as equal to 2 plus the score floor divided by, and here's kind of an interesting thing where whatever number you put here, the bigger you put it, the longer you'll be able to play before losing. Because basically this means every time we score 50, the map's going to go 1 faster. So if I put 100 here, it would be every time we scored 100, the map will go 1 faster. So what you'll see when I boot this up is just by flying for a little while and surviving, the map is going to start moving a lot faster. So there it just went to 3, and then it goes to 4, and now it's at 5, 6. But then the thing is, every time you get another score up, it's going to change speeds even faster because you're obviously clearing rectangles a lot faster. So you can play around with this value if you want. I found 50 was like just about the right speed for like a lot of challenge, but also very fun and rewarding. Okay, so I'm going to do that for map speed. And then I'm going to put a few things on the screen now. So I think we should put the score and the high score and instructions to restart on the screen. So let's do screen.blit of a font.render. And this is ordinarily a two-step process, but because these are so simple, I'm going to do it in one line of code. And I'm going to put the score inside of a formatted string. And then you need to give it the anti-alias argument of true, which just smooths it out. And then we'll have the text be black, which might seem like a bold choice since the background is black. So you could change the color of the text if you wanted, but when the green blocks are there, it'll look really clear. And then when they're not, it's okay. It's kind of fun. And honestly, that reminds me of the classic look of the game anyways. And then so we just need to give it an X and Y starting position for the screen.blit, which is a block transfer to actually draw it on the screen. So what we did here is we defined Pygame font of score with the score variable in it, color black, anti-alias true, and then we screen.blit or block transfer draw it onto the screen in position 2015, okay? And now we'll also font.render another one for high score, and I put the score at the top of the screen. I'm going to put the high score at the bottom of the screen, just like this. And so instead of 2015, I'm going to go 2565, put it pretty close to the bottom. And then I'm also going to say if not active, so the player knows how to screen.blit, so they know how to reboot. We'll say press enter to restart, and anti-alias true and color black. I just did screen.blit, but I skipped font.render. So a lot of the times in projects where I have bigger text or a ton of text, I'll do the font.renders and the screen.blits on different rows. Just kind of putting it on one for ease of use here. And I'm going to put this pretty close to the middle of the screen at the top of the screen and also at the bottom of the screen. So same text, just going to draw it in two spots. So regardless of whether you were close to the bottom or the top of the screen when you lost, this will allow you to see the instructions for restarting. And I think that's going to be it for that. So let's go ahead and take a look at some of our work there so far. Okay, so yeah, you can see high scores at the bottom, regular scores at the top. You can see now every time we get 50, you can obviously kind of visually see the map start moving a lot faster. So let's just go ahead and see if I can get to like around 1,000. Map will be moving pretty good. And then we should get the enter command. Yeah, there we go. Okay, so press enter to restart. That looks pretty good. So I'm good with text, but one thing I know I've said a few times that we want to do is we want to improve the look of the player, right? So this game is called Helicopter. It'd be nice if we could get a good looking helicopter, but we did define like a circular hitbox already that would be really useful. So what we're going to do is we're going to, instead of this being a white circle, we'll make it a black circle once we're confident that our helicopter is drawn in the right spot. But so let's make a new variable, just call it heli, which is kind of shortcut for helicopter. And then Pygame we're going to do two things. So we're going to do transform.scale. So this is going to make sure that we scale it to the right size. But inside that scale command, we're going to do pygame.image.load. And this is similar to the font rendering and blitting on one line. You could do pygame.image.load and then scale it. It's just going to be easier like this. So if you've grabbed the code and assets package from my GitHub, you'll have this exact helicopter image. But if you don't, if you have your own helicopter image, you just need to play with the scaling until you get one that you feel comfortable with. But even though we used a radius of 20, my helicopter image just has a lot of empty space around it. So I found 60 by 60 for the scaling. Really helps bring it down to a good size where the main body of the helicopter sort of works right over top of our circle here. All right, so we come down here where we have player.draw.circle, and that's where we define the player. And we're going to do screen dot blit of our heli image. And then for position, it's going to be player X, and we're actually going to scoot it back 40 pixels. Because again, the body of the helicopter is 60 wide, but we want the hitbox to basically be on the cabin of the helicopter, not really the tail. So we're going to scoot it back 40. And then for the Y position, we want this is going to be the top part of your image. And we don't actually want this to be at the center point. We want it to be up a little bit. So we'll do player Y minus 30. And let's go ahead and actually... this needs to be coordinates inside of screen.blit, just like that. Okay, and so if I boot this up now, it might look a little silly because we have a white helicopter with a white circle. But what you can see clearly is the circle lines up pretty good with the body of our helicopter. But we need that circular hitbox because Pygame is not great with checking collision with images. You have to set up kind of complex masking rules. So we're going to keep that, but we want it to be out of sight. So change the circle to be black. And now you'll have this really crisp looking helicopter, and you won't see the circle at all. And then when you hit something, you'll see the circle a little bit, but it really just makes it so that the helicopter is a lot easier to see. And it feels pretty fair. Like it doesn't feel totally broken, like, oh, I didn't collide with anything. It does feel like the image is hitting the edges just like that. So that's pretty cool. I would call that completely done. Last thing I think I want to incorporate is just in the same way we make the speed increase as we get a higher score, I think it's also fun to make our spacer more difficult as we get a higher score. So like initially the blocks could only change by 10 per piece, right? But it's actually fun to make it a second element of like progressive difficulty would be if also every 100 pixels we made it to where it could be one more. So like the spacer definitely increases the difficulty in your game. So whatever you start with, if you also made it to where the pieces could become more erratic and spread out as you played, that's another fun way to incorporate progressive difficulty. So now as I'm flying through here, every 50, I'll start to see my helicopter speed up, but then every 100, and it's kind of a subtle change, but every 100, you might notice your path gets a little bit less smooth. So that can kind of create some more funky shapes and make it a lot more difficult for the player to fly through really smoothly. So yeah, you can kind of see now we're up at like 1,000 and the shapes are getting really erratic and difficult. So speed was increasing, which is a big deal, but also our shape was increasing. Okay, so we have high score tracking. I've covered in a lot of previous videos how to read and write that high score into a text file. So if you are interested in setting up kind of high scoring that saves when you exit, check out some of my past videos. You can leave a comment asking sort of which specific videos cover that, because on this tutorial I wanted to keep it pretty short and sweet and give you guys this really cool classic game in literally 138 lines of code. Like that is awesome. We did it in under an hour. I had a ton of fun with this game. I hope you did too. Consider leaving a like on the channel, subscribing to the channel. It helps me out a ton. All the support on YouTube's been really fantastic. If you really love the content that I make and you want to help me continue producing great content, consider checking out the Patreon link in the description of the video as well. Of course, all the code and assets for this project are available in a GitHub link in the description as well. And as always, thanks for watching and good luck with your code. Thanks. Bye.